right, so our topic today is independent and dependent variables. So this kind of focuses on the idea of controlled experimentation. And so with this, let's just kind of talk a little bit about how our observations are used scientifically. Now, a lot of times, a scientific investigation requires some kind of research question. So for this, we're going to be talking about the reaction between Alka-Seltzer and vinegar. So just so you guys can kind of see what this looks like, let's take a second and let's actually see this.
Take one tablet and we add to the vinegar. Let's see what happens.
Now that we've kind of seen this reaction, let's look at some of the examples for research questions. One would be, when combining Alka-Seltzer with vinegar, how does the number of tablets added affect the final temperature of the liquid? Then another one could be, when combining Alka-Seltzer with vinegar, how does the volume of the vinegar affect the final temperature of the liquid? So we're going to kind of use these, and both of these questions require observations, and they seek to determine the relationship between two different variables. So in both of these, temperature would be one of the variables, and then in one of them, it's the volume of vinegar, and in the other, it's the number of Alka-Seltzer tablets and the effect on the final temperature. So with this kind of idea, let's kind of dive deeper into this idea of independent versus dependent variables. So with this, a well-written research question includes only one independent variable and one dependent variable. So let's start off with the independent variable. Now, the independent variable is the variable that's changed from trial to trial by the experimenter. Meaning, if you're running the experiment, you're going to be the one that's changing this thing. Now, in a well-designed experiment, there is only one independent variable, meaning you only have to look at the effect on one thing at a time. Now let's talk about the dependent variable. And the dependent variable is the variable that changes as a result of the change in the independent variable. And so with this, I like to use this kind of acronym here. And for our acronym, it's dry mix. And this is how I like to try and remember our variables. So there it is, dry mix, and dry stands for dependent, meaning the dependent variable is the responding variable. And when we graph it, this is the one that goes on the y-axis. Now on the other side, the mix, M is for manipulated, which is just another way of saying changed. So that's what you're physically changing from trial to trial. And then I is independent. And this is the one that goes on the x-axis. So a lot of times I like to use this as my kind of way of reminding myself what goes, or what is the independent variable, where it gets graphed, what's the dependent variable, where it gets graphed. And so this is something that kind of helps me out a lot. So now that we've kind of hit that, let's talk about some of our identifying variables. And so we're going to take that first research question, when combining Alka-Seltzer with vinegar, how does the number of tablets added affect the final temperature of the liquid? And so the first question is, what is the independent variable? Now remember, this is the one that you're changing. All right. And so in this case, if we think about this situation, what are you physically changing each trial? Yeah, the number of tablets. And then the dependent variable, remember that's the overall effect. That's going to be what you're measuring at the end of each trial. And so in this case, this is the temperature of the liquid. Not so bad, right? Now let's look at our other research question. So when combining Alka-Seltzer with vinegar, how does the volume of vinegar added affect the final temperature of the liquid? So I'll give you guys a second here. Think about what you think the independent variable and the dependent variable is, and go ahead and write them down below. All right, so hopefully we agree that the independent variable is the volume of vinegar, and the dependent variable is still the temperature of the liquid at the end. All right, so now that we've talked about independent and dependent variables, let's talk about this other type of variable, which is known as the controlled variables. Now, when we're talking about controlled variables, these are the variables that stay the same for every trial, because these might affect the outcome if they were allowed to change. So for example, if we're talking about like the Alka-Seltzer, one of the things that could change would be if you don't actually make sure that you have the same size tablets, or if you're talking about the volume, maybe if you have a little bit of water in there to start, maybe that could have an effect as well. Now, we'll talk about some other kind of possible controlled variables later on, but in terms of controlling variables, this means that you're paying attention to keep it constant. And so that's a big part of these controlled variables, is that you're doing the best to make sure that they're exactly the same every single time. Now, otherwise, in a lot of experiments, there are many controlled variables. And so that means that you're physically controlling a lot of things when you're setting up these experiments. And sometimes the hard part is knowing which variables to actually control. And that's a big part of science overall, is figuring out which variables to change in their overall effect. Because a lot of times in a lot of science experiments, there's tons and tons of variables, and you got to pick and choose which ones to kind of control and which ones that you want to try and change or measure as a result of your test. So with that in mind, let's kind of think about this research question. When combining Alka-Seltzer with vinegar, how does the volume of the vinegar affect the final temperature of the liquid? Now, there's kind of, in this case, because it's focused on the volume of vinegar, that means that some of our controlled variables could be the number of Alka-Seltzer tablets that we're adding, and this should stay the same from trial to trial if we're changing the volume of the vinegar. Meaning if we're looking at the effect of vinegar, we should always use like 1 tablet or 2 tablets for every trial that we do. Now, another one would be the starting temperature of the vinegar. For example, if it were refrigerated, for instance, the final temperature would be different. So that's just one of the kind of small changes that we could actually have. And so now that we're kind of talking about this idea of variables and measurements, let's kind of move on and let's talk about how do we know if measurements are actually considered good. And so for this, good measurements are considered both accurate and precise. So now let's kind of define these two terms. Accuracy, in terms of science, is if a measurement is accurate, it shows good accuracy. Now, measurements show good accuracy if they are close to the right value. So that's the key here, is that they need to be close to the right or the correct value. Now, other than that, how do we know if we're getting close to the correct value? Well, we would have to look at it. We would have to run multiple trials, or if it's something that, is a well-known thing like the speed of light, if that's what we're trying to record, then we can compare it to the actual value. And that comes down to something called percent error, which is something that we're going to talk about later in this unit. Now, otherwise, let's kind of talk about this idea of precision. So if a measurement is precise, it shows good precision. Now, what does that mean exactly? That means that your measurements are close together, or they're close to one another. And so that's the key here, is that you could be way off, but as long as you keep getting the same measurements over and over and over again, it's considered very precise. And so if we measure multiple times and get similar answers, we have very good precision. Now, with this, if we also have confidence in our method, meaning we're happy, we're satisfied, we didn't just kind of make something up as we were going along, we can guess that our measurements are also going to be accurate. Now, with this, that's one of the reasons that scientists let others know what they're doing, so that others can question their methods or process. Now, for what it's worth, this is essentially what scientists are doing when they start publishing. So they publish their results, and by publishing their results, they can let other people know what they did. And if there's flaws in their experiment, this will be where people can say, hey, here's something that you overlooked. Now, with this kind of idea of accuracy, precision, let's kind of look at this in terms of, we'll call it more simplified terms. And so if we're looking here, we got a couple questions. Which one shows good accuracy, but not good precision? So go ahead and take a look at our two boards here. So one of them, we got dots all over the place. And on the other one, the dots are grouped together, but not really close to that target. So I'll give you guys a second to kind of think about it. And we'll just call these, we'll number these pictures, picture number 1 and picture number 2. All right, so which one shows good accuracy but not good precision? This happens to be picture number 1. Now the reason for that is because if you're talking about accuracy, remember that's just comparing all the results to see how close they were to kind of the center or the target. And as it turns out, if we averaged all these dots, we would be somewhere right around the middle here. Oop, I should probably change from red to something else. We'd be somewhere right around the middle because all those dots would average out. Yes, they're all over the place, but they can average out to be a bullseye. Now, on the other hand, if we're talking about our second question, which one shows good precision but not good accuracy? Well, remember, precision is how close they are together, but not necessarily correct. And so that would be picture number 2. Yes, they're all clustered together, which shows good precision, but they're nowhere near the actual bullseye. And so this kind of brings up this question, what would be better? And actually, I'm going to let you guys think about this, and we'll talk about this later on in class. Have a good day.